Well, we will solve this problem. Well, at least we will propose how would we solve this problem. I will read what is it about. There is a block of mass m, which is this, and it's at first at rest, compressing a spring, which is this, with a constant k and a distance x. We have a constant k. Then the block is released and slides on a frictionless surface, this is frictionless, until it collides with a block of mass m that is attached with strings to the ceiling like a pendulum. The larger block has glue on the side, this part. So the two blocks stick together after the collision and swing up, they go together, to a maximum height h. Right? So the principle that we are going to work with is conservation of the energy. First, here we have to apply the Hooke's law that said us that is half the constant k times the x squared, and so this is energy that would be transformed in velocity when the block m is released and it begins to slide to collide to the other block. So we should the principle of conservation of energy tells us that the energy, as its name said, it's going to be conserved in all our system because this surface is frictionless, so we're not going to lose energy. And here we are going to use the same principle to calculate the h that is going to swing up. So we have the half of k times x squared equals to half the mass of the block times velocity squared. So the mass is compressing the spring, and after this is going to be released, and the mass m is going to slide through the surface with a velocity v. Right? So this is the Hooke's law, and then in the collision we said that we have to apply the momentum. The momentum is going to be conserved, mass 1 p 1 equals to the sum of the mass m plus capital M times a certain velocity. This momentum is valid because we are assuming that there may be forces affecting all our system, but they do not have time to act. So we're not considering time. We can establish the second law of Newton, that is force is equal to mass times acceleration, but the other way to say it is the change of the moment through the time. So if there is no change in momentum because we are not taking in consideration the time, then momentum is going to be conserved. That is p initial is going to be the same as p final, right? Okay, so here we have to apply the momentum formula, that is the mass that was the mass of the first block times the velocity that was the same as the first block is going to be equal to the first mass plus the other mass of the block that is bigger times a new velocity. That is going to be the velocity when they are both together and get stuck, and then they will swing up to a certain height. So we have then this formula, and these two objects are going to be just one object. So we're going to establish the same formula as in this point. It's going to be half of the mass times velocity squared equals to we have two types of energy, that is the potential energy and the kinetic energy, and if both are conserved in one point, like in this, that we have kinetic energy because the object is going to be moving, is going to be equal to the same energy, but in this case the object is going to stop and it is just going to have a height, right? So Here we have just kinetic energy, that is 1/2 of mv squared, is going to be equal to the gravitational energy or potential energy, that is going to be m times g times h. So in this case we can get just h, where we can cancel the mass, and we're going to have something like so. In this way we can know the new h. So I think that's all, and thank you.